in the proper configuration with water flowing through and so on, developed a very fine reactor for test purposes. The reactor was actually constructed in Idaho. Much of the actual construction of some of the parts were done right at the Oak Ridge National Laboratory in our shops, and I made several trips to Idaho to help work with the Argonne National Laboratory group in actually finishing that reactor. At the same time, there became evident the need for better methods for separating the fission products and plutonium and uranium. The original process, as designed for the use at Hanford, separated out the plutonium but left the uranium and fission products together, and they were both stored in big tanks out at the Hanford plant. And of course, as the operations proceeded and plutonium was extracted from these, great quantities of uranium piled up in these tanks, and there was a great economic incentive to develop a process which would separate out the plutonium and then also separate out the uranium, and leaving the fission products by themselves. Well, at that particular time, there was a compound discovered, tributyl phosphate, which with proper extracting agents would do a wonderful job of fitting into separating out uranium away from plutonium and the plutonium away from the fission products. And so we had solved this particular problem, and it was called the Purex process for plutonium uranium extraction. This was actually put in at the Hanford plant for some of the processing, and all of the processing at the Savannah River plant, which was constructed during this period, used the Purex plant. And to this day, throughout the world, the Purex process, slightly modified, is still being used for the processing of spent fuel. In addition to this, of course, the Oak Ridge National Laboratory participated in the project designed to furnish a reactor which would be suitable for airplane propulsion. At that time, there was a concept which was developed using a molten salt which contained U-235, which circulated as a fluid fuel reactor. And on the experimental scale, it worked very well, and in addition to that, it showed great promise as a continually operating plant whereby the fuel reprocessing could be done more or less continuously. Unfortunately, the project did not get very much attention from the industrial companies, but it was a great success as an experimental reactor which would accomplish that objective if that objective ever appears to have validity in the future. Another project of great interest at that time was the gas-cooled reactor, and there was very much pioneering work done on the gas-cooled reactor and subsequent reactors which were built in Colorado and another one in Germany. I used much of the technology developed at the Oak Ridge National Laboratory at that time. Perhaps one of the most interesting things that developed during that time was the participation of the Oak Ridge National Laboratory in the Atoms for Peace Conference. It was on December 8th, 1953, that President Eisenhower delivered a speech at the United Nations offering to contribute both enriched uranium and scientific and technical know-how for peaceful purposes. And this caught the imagination of the world, and subsequently a conference was arranged to be held in Geneva in July and August of 1955, and the entire world sent representatives to that conference. In addition to many of the exhibits involving radioisotopes, there was a very interesting exhibit which I think really made the success exhibit-wise of the whole conference. About 6 months before the conference was due to open, Dr. Tom Cole and Al Weinberg came to the office to discuss offering to actually construct a reactor and place it in position in Geneva to actually have an operating reactor right on site for the Atoms for Peace Conference. It sounded very daring and almost foolhardy at the time, and today, of course, it would be unthinkable. But in the short period of 6 months, an operating reactor was constructed, and all of the parts were put together in Oak Ridge and tested and placed on a plane for Geneva, where we had a crew waiting to put the reactor together in a building which was designed and put up for the occasion, just to emphasize the peaceful nature of the exhibit. It was placed in a building which had somewhat of a resemblance to a Swiss chalet. It was a very efficiently designed building and served the purpose for housing the reactor and the accompanying exhibits very well, and indeed was the hit of the conference. I can very well remember that Dr. Louis Strauss, who was then the commissioner of the Atomic Energy Commission, said that he had seen an awful lot of exhibits and a lot of expositions that were very wonderful, but were completed the week after the exhibit closed, and he wanted nothing to do with such an exhibit. Consequently, we scheduled the construction and operation of that reactor practically down so that every hour was accounted for, and nobody was allowed to fall behind in the design and construction of this reactor. Well, there were literally dozens of other very outstanding programs that were carried out during the period of 1950 to 55, and it probably was one of the most exciting periods of my life to actually go through and see the successful completion, some of which I observed in the test tube and then brought to fruition in multi-hundred-million-dollar projects that operated very successfully from the start.